Hello and welcome back to Fullerton College's pre-press class. This is Professor Ben Hewitt, and today we're taking a look at PIA's pre-press trainee manual, section 6.4, advanced proofing. Let me make sure I'm sharing the right thing for a moment, and we're good. Excellent. So the learning objectives of this particular section are to take a look at what proofs are and why and when they're used. We're going to look at the difference between hard and soft proofing technology. Hint, it has nothing to do with alcohol content. We're also going to look at the different types of digital proofs and what the differences are between them, advantages and disadvantages, and stuff like that. So let's jump straight in. What is a proof? Well, the answer here in red letters, which means is very important, mind you, is that it's a preliminary representation of what the eventual printed piece will look like. Now, those who've been around me a little while already know that I have a strong distaste for reading a slide directly to you. I make exceptions for things like red letter slides when there is a definition that really needs to be known. So really understand that a proof is a preliminary representation of what the eventual printed piece will look like. It's a way of showing a customer what they're getting before you make it. Now, they can be close or not so close depending on what your goal is, because there's different types of proofs, which is, and there's more than one way of calling them different types. In this case, I'm going to say there's different intents. There are different purposes of showing a proof, although they all fall under the general idea of giving a client an idea of what they're getting. But depending on what you want them to understand and what you need to get from them, it may not need to be that close a representation. So the two types, the two methods of proofing here that we're talking about, methods is the wrong word, the two kind of business purposes of proofs, we'll go there, are content and contract proofs. Content proofs are more common than contract proofs. Content proofs help your client look at the print file you're going to produce and ensure that the information is correct, that the pictures are right and in the right place, that the words are all in the right place and spelled correctly, making sure that nothing got left out, proofreading, making sure it's all there. That's what a content proof is about. It's about the content of the design. Was it created the right way? And is this everything you want in here before I go ahead and print it? That's a content proof. Now, a contract proof, sure, it answers those questions too. But the key difference here is a contract proof is actually a prediction of what the process or what the actual thing is going to look like when it's printed on the final press. And it is intended to show an accurate prediction of what the color is going to look like. So content is all my stuff correct? Contract is, did it get those colors right? You should be able to, from the knowledge we have so far in the class, surmise from this that, in fact, a contract proof is much more difficult to produce than a content proof. Digital convergence. So these days, as everything has gotten digital, you're seeing more and more of the two types of proofs being used at the same time. Nowadays, you can give someone a proof that has accurate color, but also is usable for content use, so they can check their spellings and make sure the correct photos were used, and to make sure that they bought them and took those watermarks off from the placeholder pictures. Go ahead and laugh. I've seen that one come through on actual books that I ended up buying to show people that it had those problems in it because, anyways, it could do that, but it can also show you correctly what it's going to look like when printed. Digital proofing devices continue to improve. That still is true today. They're getting better and better and better. And don't forget that if the final job is going to be run on a digital press, your proof can be pretty exact because you're going to run it on the same press later. And you will then know how that particular Xerox or HP is able to produce that particular design. And people can see exactly what they're getting. But if you're going to run something offset or flexo or screen or through another method, then you start to have to match what the digital proof looks like to what the actual thing is going to be on the real machine. And by real, I mean the one that's going to be used for the final project. Proofs can be hard or soft. Let's talk about hard proofs and soft proofs. Hard means it's physical. A hard proof is a proof printed on paper or something, mostly paper, that you can physically hand to your client and say, here, hold this, look at this, sign here, please. That's a hard proof. And they can be made through inkjet printers. They can be made through toner-based printers. They can be made through ablative proofer devices, which sound really cool, but I've sadly never gotten to use. And there are others out there too that can do that. A soft proof, think software, not soft drink. We're not talking about bubbly colas or anything here. A soft proof means it's on the computer. Means there is no hard proof. That means instead of printing out a copy of it on a piece of paper to hand somebody, you can show them on a computer. You can email it to them. You can have them sign into a special proofing system online and view it from the comfort of their own office. So digital hard proofs. Inkjet is quite common. Inkjets, including large format inkjets. Large format, why is that? Well, large format because that lets you print a whole signature instead of just a single sheet of paper. Because the page size can match the size of the printed sheets that you're going to run on the large offset press. That's why inkjet. And inkjets squeeze little tiny drops of ink through a nozzle onto your substrate. There's also non-inkjet. Both on this one, you can use a toner-based laser printer, like a good Xerox or Canon type press. Or if you want to go totally crazy and you're going to show them exactly what you're going to run on your HP Indigo, you can run it on an HP Indigo. That's also a non-inkjet digital press. However, there's also something special just for proofing called ablative printing. And these we'll talk more about what they do, but basically they start with sheets of colored pigment, and a laser will remove some of that, and then the pigment will be transferred onto a final substrate. This sounds like a really wonky workaround, but we'll explain it in a moment. It's not as wonky as you think. Once you understand the purpose and the goal of doing this, it actually makes a lot of sense. But we'll get there when we get there. First, let's talk about inkjet printing. So continuous flow means that the inkjet is always leaking, so to speak. It means that that nozzle, as long as the machine is on, is squirting out ink. Hold on a second. Okay, hopefully that didn't cover up too much of what I was saying before I paused. Sorry, as I mentioned before, I happen to live near two small airports, one large international airport, and there's an Air Force base not that far from here. So I get some loud air traffic from time to time around here, and it can drown me out a little. It's also mighty distracting because I love to see what's flying overhead. It's like industrial bird watching. Anyways, so continuous flow inkjet is always streaming ink through the nozzle. It's like a hose. It turns on, it just keeps going. Sometimes, or most of the time, it is brought back to a recirculation system. So the ink flows and drips down like a fountain, like not like an ink fountain, but like an actual fountain. You toss your coins in, the water comes out, then it goes down below and it gets pumped back through and comes out again. That's a continuous flow inkjet. And with that, there's an electric field that sometimes static charges the ink droplets to go to the substrate, and sometimes it static charges them to go to the recirculation system, but it continues to flow. I've never used one of these personally, but they're out there. Here's a picture of what a continuous flow inkjet looks like when it prints. You might recognize from our previous chapters that this is in fact a stochastic or FM screened halftone. The halftone dots are determined by the size of the inkjet drop. They don't really vary in size much. They're mostly uniform, but their spacing changes according to how dark or light they want to be. There's also the drop on demand, which uses something called a piezo tube that squeezes out drops of ink. In this one, there's more than one way to do it. You can use an electrical pulse, you can use a piezo tube pulse. Sometimes it's heated so the ink will expand and cause itself to drip out. There are lots of ways of forcing it out, but in this case, it only drips when you want a halftone dot. Now for this one, the ink can dry much faster. For quicker drying inks, you drop it out only when you want it. The recirculating system, by nature, must be a slower drying ink because otherwise your ink would dry out before it recycles back through a second time. Drop-on-demand inkjet looks somewhat similar to the continuous flow inkjet. One of the things of inkjets is, as you're dropping individual liquid drops of liquid ink, the edges of every halftone dot in an inkjet print are a little bit fuzzy. They're a little bit blurry, like a watercolor painting. There's always that edge of where the pigment kind of soaks out into the paper. Now, ablative technology. Let's talk about some cool stuff here. Ablative means you are removing pieces. That's what ablative is. So from nerdy tabletop games I used to play, there are spaceships with ablative armor where like, it gets shot. And I'm going to have to edit this out. Anyways, we'll see if I actually go back and edit that. Anyways, yeah, that was from a space game. But one of the space fleets had ablative armor where it would take hits and the armor would protect the ship, but then the armor would fall off. It takes a hit, wrecks the armor, but the ship is unharmed. Anyways, ablative means you are removing parts to make it work. In ablative proofing technology, you have a laser that removes part of what's called a donor sheet. The donor sheet is totally covered in the pigment of the ink, whatever the four process colors, or if you have them for spot colors, which are also available. The whole page is covered. The laser removes the parts you don't want, and the parts that you do want are transferred from the donor to the substrate. This sounds like a really wonky system when there are perfectly good inkjets and perfectly good toner-based printing. Why would you use a donor sheet and the laser to transfer from one sheet to another to print? Isn't that overly complicated? What the heck would that? Why is that good for anything? The answer is, also I should mention before we get to why, this is expensive. These machines are costly. They're very precise. They're basically a plate maker that makes a single sheet of printed paper instead of a plate. So it's that level of complexity and expense. And then the donor sheets are pre-coated and they cost a lot of money. One of the key factors here, if you look at it, the donor sheet here says it can go up to 2,400 DPI. You might be thinking that sounds like a very specific number. If you've been paying attention, 2,400 DPI is a standard offset printing resolution. So what's going on here is you're able to precisely match the halftone sizes and patterns of a plate maker, which means you are able to give a much more precise, exact preview of what you're going to get. Customers who see a laser ablated proof are seeing the halftone dots that the plate maker is going to make precisely. So not only can they see the colors they're going to use, not only is it capable of printing on the exact same substrate, because they're very unpicky, they're very reasonable in what you can ablate onto. You can use the exact same stock and the exact same colors of ink, the exact same halftones. So when a client sees this proof, they know precisely what they're getting. This is useful for large, well-paying, and picky customers who have corporate branding they're trying to uphold, who want to make sure that their corporate colors are represented correctly and everything looks exactly the way it's supposed to do, and they are willing to pay the extra money for that guarantee. So that's laser ablation. Tune in next time, and we'll carry on with more proofing.